Hey there, everyone. Ryan Schewel. Welcome to my analytics channel. So today I want to talk about analyzing NYC job posting data and how can we derive value from this and just do some exploratory data analysis. It's going to be pretty simple and pretty straightforward, nothing too complex, nothing too heavy. So you can just settle in and watch the video for the next 15 to 20 minutes. I'll try to keep it under 20. Most of these are relatively bite-sized and chewable and digestible. So why would we even want to analyze this kind of data, like job data? What kind of benefit do we derive from this? What are we doing with this, right? So workforce planning and budgeting, we can identify which departments are growing and which are shrinking. How do we allocate resources? How do we manage the business? How do we manage the budget, right? How do we allocate funds? How do we forecast future staffing needs? Are there going to be shortages? Are there going to be surpluses? Things like that, right? So policy evaluation, tracking how well we're doing, analyzing equality, inclusiveness, monitoring shifts and trends and patterns over time, transparency and accountability. These are two pretty important words, right? I worked on Wall Street for 22 years. I worked with a lot of people that have zero accountability. They'll blame other people for their problems. They have zero transparency. They'll keep it close to the vest. They won't tell you anything. And all my videos, I try to share knowledge, drop knowledge, and make everything completely transparent and understandable so you can learn and grow and develop, right? If you hide everything because you have some kind of twisted job security, instability or uncertainty, that's kind of a problem that you have to deal with, right? You have to go see a psychologist or something for that. But I try to be all transparent and accountable. So labor market analysis, that's important too. Identifying high demand roles. Again, trends, shifts. Where is the job market going? Everything is going to AI now. That's a huge thing, right? Understanding artificial intelligence, how to use that in the workforce. I've got several videos, how to use AI agents, how to create agents, how to deploy agents, things like that. You can check that out on my channel. Automation and efficiency. I think this is extremely important. I spent 1 decade of my career on Wall Street, first 10 years of my career doing nothing but automation. So how do we automate tasks that are repetitive and redundant? I've seen people take 8, 9, 10 hours to do something that I could write code for, and the job is done literally in 10 seconds, right? So if you can do your entire job for 1 day in 10 seconds and you're creating reports and loading data and transferring and transforming and booking and scheduling, if you can do that in 10 seconds and then it frees you up for the rest of the day to do things where you actually have to use your brain and get engaged and learn and grow and develop, I think that's very important, right? You can do things that have meaning and purpose instead of just redundancy and repetitiveness, right? That gets very what's it called? Monotony. It gets very boring and redundant very, very quickly, right? So just understanding how to make improvements. I used to call it process improvements. So if you can make these improvements, then that's exactly what you should do. So this is the source of the data over here. It comes from this, okay? You can download the file. If you go over here to export CSV download, click the download button, you'll have everything you need and you can follow along, and I'll share all this code with you guys so you can copy and paste it into your own Jupyter notebook and run it and see exactly how everything works. And I'll put the link to that URL that you just saw at the bottom of this Jupyter notebook. So here it is. This data is on my desktop right now. This is a CSV file. I'm loading into this data frame. And this is what we have. Number of positions, business title, civil service title, title classification, title code, job category, salary from, salary to, right? So this is the range. There's always a range. I've even seen jobs that have the range that's exactly the same number. Like the range goes from 75,000 to 75,000. That's not really a range. It's like just two identical numbers, but usually you'll see a range. Work location, division, job description. So this is the data that we're looking at. Okay, so we'll jump in. So we go down here and I'm going to create my first chart right here. So we have pandas. We're doing the import, right? That's what we did. Import the data into a data frame right here. So it comes from this source into this destination. There's the destination, right? So there's the from and the to. And we have the salary range from and the salary range to divided by 2. So we just sum these together. take the average. There's a few different ways to do this. We can take the mean. Dot mean is like a way to do exactly the same thing. Usually in the Python world, there's many ways to skin the cat, right? So you can achieve your objective using multiple different methodologies or practices, right? So we go ahead and get the average salary. We're dropping anything that has a nan or not a number because that's basically nothing. There's no record, or something's missing, or something just doesn't belong there. Although I think the data is pretty complete in this example, but in the real world, you do deal with nans. Sometimes you have nans, you have to impute missing values. Sometimes you have to use data science or some kind of machine learning technique to impute missing values. Sometimes if you have so many missing values, you can't even do the imputation. You just have to drop those records, right? Because that column is going to be useless. It's not going to help you at all. So anyways, we have the data frame. On the x-axis, we have the business person title. On the y-axis, we have the average salary. So x is the name, the y is the number or the count or the sum or the average. In this case, it's the average. That's normally how it goes. This is the typical graph. You can take that and transpose it and flip it and have all the x's as the counts and all the y's as the name. Normally, you don't see that, but you could do that. I've seen that before. Sometimes it makes sense. Normally, that's kind of nonsense. You don't see that too often. But here's the tick angle. We're here at 45 degrees. The width of the chart is 1100 pixels and the height of the chart is 800. So the code does exactly what we tell it to do. We have all this information, but if you look at this, it's so busy, it's so convoluted and complicated. I can't take this to any stakeholder. I've worked with hundreds of thousands of people over the course of my career. Nobody is going to take this and look at this and say, wow, thank you. You did such a great job. This is a job well done. Nobody's going to look at this, right? They're going to see this and just throw it immediately into the garbage or delete the email, right? Let me take another approach and try to do this a little bit differently. Again, we have the job category on the x-axis, the average salary, and here's the data frame. This is the data source. But again, we have this thing, and this is even worse. Now, I can't even tell even what's going on. So the point is, sometimes you have to make a couple of mistakes. It's not going to be perfect on the first attempt, right? But you have to think outside the box and think, okay, so there's too much information, TMI here. How can I derive some kind of satisfaction or utility or usefulness from this? How can I make this useful? So when I present this to a stakeholder, they're going to say, okay, this is great. This is good. This is a good first draft. This is something I can work with. If I give this to anybody, they're going to say, get the hell out of here. Like, this is nonsense. I can't use it. If you zoom in, like, you can see what's being done here. Okay, I did exactly what I told it to do. All the, these are called box plots. All the blocks, sorry, it's so hard to say this stuff. I'm sorry, guys. It's very hard for me to just, the box plots are working exactly like they're supposed to work, right? It does exactly what I tell it to do, but it's just too overwhelming. We have to come up with another solution. So I think if we look at the 10 largest salaries and look at the dispersion of the salaries, that might be more useful. And if we look at the bottom 10, that could be useful too, right? So let's take the n largest, number largest 10, the index in the Python world is just the count with rows, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. We're going to look at average salary and business title. Again, looking at the data frame that goes back to the original data frame that we had right here, right? So we're taking the source and just transposing it into a form that makes a little more sense. So I just ran this. Now we have the top 10 salaries, okay? So I have the chief surgeon, health management division, and if I zoom in here, I don't think there's going to be too much deviation. Yeah, it's just like one salary. I think it's probably one person. But this guy's making 210K. This is 215. Deputy, what's this? Deputy Commissioner General Counsel makes 212, I think. Yeah, 212. And then we have 225. This guy's doing okay. Chief People Officer. This is what? It's not popping up. Chief Deputy Commissioner, I think that's what that is. Yeah, okay. And this guy's making 225. I think in the New York City government area, institution, whatever you want to call it, I think the cap is 225 probably. It seems like that's the top one. And then we have like a few levels below that. Okay, and we have the Assistant Director, District Attorney, Bureau Chief. So these are the top 10. on the payroll in New York City. Then if we go to the lowest end, we have this view, and we have public art collection management intern making $16,000 a year, kind of low, but okay. If you live at home, I think that's doable. 16.68 legal college intern. These are internships, and civil intern and intern. But anyways, the point is you take a lot of information that we saw before, which is doing what we tell it to do, right? But it's kind of useless because it's just too much information. I can't tell from this perspective what the heck is going on, right? Or I have to zoom in multiple times. It's just not super useful, right? But if I take the top 10 and the bottom 10, I can get more insight into payrolls and who's making what and what the titles are, and then the income distribution for each. And there's no distribution here. If you look close at this chart over here, these are called box plots, right? And you look a little bit closer. Let me zoom in here and then zoom in on this thing right here. So here's the box plot, and you can see how these things work. I have several videos on this. So you see the average, which is the mean. You see the top, the bottom, first quartile, the third quartile, and everything in between. So the lower and the upper and everything. So these box plots, I wish I didn't call that, guys, but that's the term they gave it. That thing, that's the distribution of data, and that's how it works. So, and you can see that some of these people have long titles. There's a way to handle that. You can slice the titles to the first 30 characters. So you take 0 to 30, and you can append that as a new title and make it shorter. This is the business title short. So we're creating a new column, data frame. Business title short is business title, that string, that slice, 0 through 30, and then ... just to say that there's probably more. If we can't get everything in the first 30, then we have an ellipsis. It's called an ellipsis. ... is the ellipsis. There's a little bit more to the title. But if you have these long titles like you see over here, like some of these things, I can't even pronounce what this is. Community Program, Communications and International Government Affairs, Engineer, Architecture, Planning, Policy, Human Resources, Analysis, Social Services. So that's way too long. Like nobody's gonna be able to pronounce your title, right? So sometimes we have to truncate the title or give it some kind of ceiling, right? If you have a ceiling, you have a top level, and it can't go above that. So another way to look at this data is by agency level, hiring trends, and look at averages by sector, by salary, by agency, identify which agencies are hiring most frequently and paying the most. So again, we'll start with our data frame. We take the agency value count. In the data science world, most things, to be honest, are just counts or averages or sums. So there's all kinds of metrics. You can do z-scores and standard deviations and normalization, standard deviation, or standardization, sorry, mispronounced. And there's all these different metrics, so many, I can't even describe how many, easily hundreds and probably even thousands. But to be honest, like most of the time, probably 95% of the time to 98% of the time, you're doing counts or you're doing averages or you're doing sums most of the time. And there's exceptions to that rule for sure. And I have videos on that. I have over 300 videos on my channel now. But most of the time, I'll be totally honest, it's a count, it's a sum, or it's an average, which is a mean. So you'll see that a lot in this video, and it totally makes sense, right? We're counting the top 20 by posting. This is top 20 agencies in the New York City government system by job postings. We have Department of Environmental Protection. That's the number one, 1,310. And again, we're doing counts, right? Everything, most things, not everything, but most things are counts, sums, or averages. So we're counting the top 20. Here, it's Department of Mental Health and Hygiene, Department of Social Services, so on and so forth. I don't have to go through every single one. This is the District Attorney Office. And down here on the least of the top 20, Department Planning is Department of City Planning, and they have 42 job openings, and the top agency has 1,310 job openings. Okay, so that's the top 20. So we can compute average salary per posting. Okay, that's another way to look at this, just to understand the data and to try to get a better appreciation for what's going on here. Again, we have data frame. salary from, salary to, and there's a couple ways to get this. We're just dividing by 2, keeping it very simple, dropping anything that's blank or missing. We're looking at average salary by agency. You take that, put that into the top agencies by salary, Control F. We'll show you that that becomes a new data frame. So we create a temporary data frame, load that into the Plotly chart. So I love these Plotly bar charts. You can zoom in, you can zoom out, we can zoom in here, double click to zoom out, and I get the original chart. So here's the top 20 agencies by median salary. Median is the average salary here. So we have municipal water finance authority, I guess, and this person's making 128,000. Office of the comptroller, average is making 122. Top 3 rounding off here is NYC Employee Retirement Systems, making 119, almost 120K. And going down to the bottom, Office of the Mayor, 87,000. Campaign Finance Board, 85,000. And Mayor Office Contract Services, 85,000. Okay. So again, just different perspective, managing the data, grouping by, sorting by, counting, summing, averaging. A lot of data science, I would say most data science is those 3 things: counting, summing, averaging. You see that over and over and over. And again, there's exceptions, but not too many. I mean, 95% of the time, this is how it goes, right? So again, n largest is 20. I'm taking the top 20 because if I don't, we're going to see everything on God's green earth, right? And that could be too much information, like we saw initially. That was the first example, and I only showed that just to show you what not to do. Sometimes I show people, sometimes in my videos, I like demonstrate what you should not do, because you can make a mistake and fall into that pit, and then you have to dig yourself out. So if you can just avoid the pit altogether, that's better. If you can anticipate what could happen and just avoid those problems, that's better than making the problem, or learn from other people's problems, or learn from other people's mistakes and don't repeat that mistake. That's the best way to learn. You can learn from your own mistakes. If you make a mistake and you repeat the mistake over and over, that's just dumb. The smartest thing you can do is see other people make mistakes and learn from that and avoid it altogether, right? So I'm trying to demonstrate that. So here is the top 20 agencies by job count, okay? So here's the Department of Environmental Protection. Here's the Department of Health and Hygiene and the Department of Social Services by job count, and Department of City Planning over here is the last by 42, and over here we have 1310. Okay, so kind of like the same thing we saw over here, 1310 and 42. Okay, just different ways. Like I mentioned a few minutes ago, you can take these charts and transform them and transpose them. Maybe I'll put that underneath. Actually, I'm thinking about it. Put that directly underneath there and put in a cell. So this is just a chart that has been transposed, but it's a different perspective, and one can be preferred over the other, or it could just be personal preference. I wouldn't say like absolutely one is the better. Most of the time, you'll see the terminology or the language or the text on the x-axis and the numbers on the y. But if you want to transpose that and flip it, like we see right here, this would be a transposed chart. That's totally fine, right? Sometimes that's a good way to do it. And over here, you can see this horizontal bar chart. Sometimes that works. It's kind of personal preference, but for the most part, you will see like text on the x-axis and counts or sums or averages on the y-axis. So here we have the average salary, got median, and here's the n largest 10. So we saw that before, n largest 20. This is median. This is the most common number, right? Mean is the average. And we saw kind of the same thing over here, n largest 20 over here, right? And these are value counts. So there's a few different ways to do that. Here's the median. This is the most common number. The mean is the average, and the mode is the middle number, right? This is basic statistics. I believe that's the way it goes. Let me see. No, I haven't looked at this in a while. I think that was it. Let me see. Sorry, sometimes I go off on these tangents. I just have to fill in the knowledge gap here. Mean, median, mode, a way to look at the center or the typical values. Okay, here, maybe this is it. Okay, I won't go too far down this rabbit hole. I thought we could find it. Oh, I think I just saw it. I think I just saw it. Okay, mean is the average, median is the middle value, and mode is the most frequent occurring. Okay, so this is probably a good chart. I just saw this over here. All right, so yeah, I think that makes sense. Okay, so mode is the most frequently occurring, median is the middle, and mean is the average. Okay, so that's how you can learn that. And these are all good, right? So just different ways to analyze the data. You can take the mean, median, or mode. It's really up to you, right? But it really depends how skewed the data is too. If the data is pretty normalized, these are all going to be basically the same thing. If it's very skewed to the left or very skewed to the right, they could be very different things, right? So it's really what kind of message are you trying to communicate, and who is the receiver of that message. Then you have to define the create metric here to use, right? So again, same thing as before, median salary, Control F, median salary by title. So that becomes a temporary data frame. Median salary by title index is just the horizontal, again, the horizontal text that we have. The Y is the vertical. This is pretty common. Sometimes you flip it like you saw before, but this is pretty common to see that. You add in a title, you add in the labels right here, business title and mean salary. And then this is the width and height of the plot in pixels. So here's a time series chart that shows temporal or time trends based on posting date and the count of the number of postings. So if you go back to 2021, this is kind of post-COVID. We're kind of in lockdown period right now. COVID was like the craziest thing I've ever seen in my lifetime. And again, I think like most of that was just nonsense, to be honest. But some people were like really upset about that thing. I think it was mostly just distraction. So anyways, so this is post-COVID right here. You have one job posting, nothing's happening. The whole economy is shut down. Planet Earth is shut down. I'm not sure why. Then you have a few more over time. Now people get the vaccines. Things are starting to open up. Now you have 26 job postings, 50, 27, 72, 92, 149. Now it takes off, okay? The rocket has left the launch pad, blasting off 191, 405, 521. So we are in job hiring spree 741. The max is 1231, and that drops off a cliff here. So I think this is a data quality issue. We're down to 88. I think something in the system didn't get updated. I think there was a mistake here. This could be real and true, but again, this is New York City government data. So do I have high confidence that this is actually correct? I mean, for the most part, yeah, I think so, but this looks weird to me. So I think there's a mistake. If I had to hazard a guess here, I would say this is probably a mistake. I don't think this is accurate. I think a system went down. One ETL process didn't run. Some loader didn't load something. I think, because I don't know how you go from 1,231 job openings down to 88. But maybe I'll give them the benefit of the doubt. I'm just reporting what's in the data. I'm not manufacturing the data or modifying it whatsoever. So again, we have our data frame, business title, value count, largest 20. So you see this theme over and over, and we're doing value counts again. What are the top three? Counting, summing, averaging. The average is the mean, right? We just saw that. So hopefully that resonates by now. Top job titles. And then we feed that as a temporary data frame. So we always manufacture the data frame, or set the data frame or create the data frame and feed it into the Plotly chart, right? So we have the top titles. Here's the count. Here's the business title. And we can do the other way around, right? Like maybe that might make a little more sense. Let me see. Sometimes you have to just test this and see what works. Oh, that was weird. Did you see that? Yeah, so maybe we have to do it this way. Okay, so count. Yeah, so you kind of have to test it and see if it's going to work. I think just I think because this title is so long, Public Health Inspector, Bureau, Food Safety and Communication, Sanitation, that is a mouthful, guys. Like I can't talk too well, even though I grew up in this country. Like I just can't talk like normal, but I can just barely pronounce it. I think when you take that and you flip that on the x-axis, it's so long it condenses everything because it has to fit into that space. So in this case, like we have to use a horizontal bar chart, okay? Because otherwise everything gets so jammed up in the other pivoted view, like it just completely breaks down. It doesn't work. Okay. So anyways, let's look at another view here. So this is, again, data frame, work location, value count. We've seen this over and over. And you reset the index just so it doesn't like create another index. And then you have a multi-index. That's a whole other thing. I have another video on that. Reset the index just to handle that automatically. Work location and job count. So here are the locations. So this has 539 people at this location, 9605 Horace Harding Expressway, and this 4209 28th Street. So that's a big government center, 3030 Thompson Avenue out Long Island City, Queens. Actually, that's close to where I live. I should know that one, the Thompson Avenue. Oh, I do know that. I know where that is. Yeah, okay. So 55 Water Street. I used to work in that building downtown, so I know where that is. 400 people work in that office. And then you have 33 Beaver Street, and I know where that is. It's close to Water Street downtown. And you have 73 people that work in that office. So the New York City job force is just spread all over the place. That's what that means. So now we have career level distribution. We can count by career level, experienced, entry level, manager. Here is experienced, non-manager. So clearly most of the NYC staffing labor force, whatever you want to call it, is 4725, experienced non-manager. Some are entry level. This is more like a admin, maybe, first job out of school, maybe even intern could fall into that. Manager, 572 managers. Student, maybe this would be more like the intern, right? Maybe the intern, this could be the first job out of school. And executive, 87 executives on staff, okay? So that gives us good insight into that. Salary range from and to, we have an average salary and group by career level. So this is interesting too. So average salary for executives, this totally makes sense to me, 161,000. And this is the average we saw at the beginning. I think the top was 225 and the bottom was, what was that again? I actually forgot. 225 and, 225 down to 210. And it's actually a little bit lower because we're including some executives actually make less. Remember, we're looking at like the top 10, I think with that's what that thing was, right? But you can still have some executives making less money because the average is the average, right? If you have 225 and maybe someone's pulling it down, trying to think now, like 140, 150 range. If you have a couple people making 225 and a bunch making 150, the average could easily be 161, right? An average is just an average. You can have a river that is an average 1 foot deep, but a person, there's no saying, a person can drown in a river that is 1 foot deep, right? If the average of the river is 1 foot deep, but you have some parts of the river that are 1 inch and some parts that are 10 feet deep, but the average is 1 foot. An average is just an average, right? It could be very enlightening and very informing, but it could also be very misleading. But anyways, this is the average, 161 for manager, 130 for experienced, average is 78, and entry level 60, and then student basically makes nothing, right? That's free labor, and they probably should be making something. So I think this is the last chart here. I like this a lot. This is called a tree map, and it shows you the proportion of counts of each job category relative to all the others. So the bigger box has more counts, right? And again, this is Plotly. So if you zoom in here or zoom out, you can see all the details. That's why I love these Plotly charts. Very informative, very enlightening. So the counts for engineering, architecture, and planning, if this is your title, we have 889. And the bigger one always goes up to the left, right? And the smallest goes down to the right. So the Northwest is the biggest. The Southeast is the least, right? So we have one over here, green job, finance, accounting, and procurement. And one person works with that in that job category, and 889 people in New York City work under the umbrella of engineering, architecture, and planning. Over here, kind of hard to see it. 682, 582, what's it saying? Can't really see it because it's in a weird color. This is 442, 409, 336, 328, 303. Okay, so on and so forth. So you can see the bigger goes up to the northwest and the smaller goes to the southeast. This is a tree map, and I think this is very informative and very useful and very insightful too. So here's the data source. I'm going to wrap it up here, guys. I think this is a good exercise. So nothing too overwhelming, not too sophisticated, pretty straightforward, but I just wanted to show you how to analyze just a generic data set that I found online, how to do the grouping and the plotting and all the charting, and just some basic analytics. Again, counting, summing, averaging of these different groups, and then displaying it in a plotly chart. I think that's very useful, very helpful, and that can serve you well in your career and the analytics world, whether you're data science, whether you're in the data science space or machine learning or statistics or mathematics or even computer science or even finance or even like some kind of analyst. I think this can all serve you well. All these things are relevant and important. Okay, so that's it. I'm going to wrap it up, and I will see you soon in the very next video. Thank you. Bye.